Hey there, interwebs, and happy Pi Day! If you're new here, I've been making annual Pi Day videos since I was a fresh-faced freshman in college, and frankly, it's getting old, and, dare I say, uninteresting. That's why today I'd like to talk about a different mathematical concept: interesting integers. Obviously, pi isn't an integer, but if I were to include every irrational number under the sun, we'd never even get to 1, and the first number I want to discuss is 11,630. Do you know what's interesting about 11,630? Nothing. Nothing is interesting about the number 11,630. In 2009, it was carefully determined to be the first uninteresting number. Of course, keen-minded viewers will notice a problem with this. It's called the interesting number paradox, and it states that all natural numbers must be interesting. Also, when I say numbers for the rest of this video, I am referring only to natural numbers. Those are the non-negative integers or counting numbers such as 1, 2, 5, and so on. Obviously, when someone starts making claims on the internet, you should demand proof, and when mathematicians are involved, that's probably going to be proof by contradiction, which works as follows. Start by taking the statement you're trying to prove is true, then determine the opposite claim. If you can prove this new counterclaim is false, then congratulations, you've just proven that your original statement must be true as a logical consequence. We want to prove that all numbers are interesting, or, in other words, uninteresting numbers don't exist. The opposite is simply that uninteresting numbers do exist. Thus, there must exist a set of natural numbers which are uninteresting, and this set must contain a smallest element. This element, however, would be interesting merely by its very nature as the smallest uninteresting number. It must therefore be rejected from the set, but without it there would still be another smallest element. The only way for there to be no smallest element of this set is for it to be a null set, which is a set containing no elements whatsoever. This means that there would be no numbers which are uninteresting, and that contradicts our initial statement that uninteresting numbers exist. Ergo, by contradiction, we have just proven that all numbers must be interesting. Of course, what we've actually done is generate a paradox by creating a set of numbers defined as numbers that do not appear in any set, including this one, and it has the same fundamental issue as the barber paradox. That's the one which states that the barber of a particular town shaves all of the townspeople who don't shave themselves, so who shaves the barber? The only solution is that there are no townspeople, no barber, and no uninteresting numbers. So what about 11,630, then? How is that uninteresting? Well, obviously it depends on your definition of uninteresting. Mathematician cum author Alex Bellows suggested that it's a number not to have its own page on Wikipedia. Another suggested definition is any number that can't be expressed in 5 words or fewer, but you have to be careful with this one. 1,729 seems boring at first, until you realize that it can be expressed as 1 cubed plus 12 cubed, or 9 cubed plus 10 cubed, or simply the smallest taxicab number. My favorite definition, however, is any natural number that does not appear in the Online Encyclopedia of Integer Sequences, or OEIS for short. In addition to being a fantastic resource, the OEIS is also like Wikipedia for math nerds, but almost completely unheard of outside of that circle. It's a giant repository of number sets, which means this definition is perhaps closest to the one which produced our original paradox. It's also constantly growing. At time of writing, I just checked, and 11,630 appears in no fewer than 9 sequences, but if you replay this video, you'll notice that I specifically said 11,630 was the first uninteresting number, not the smallest. It was the smallest as of June 2009, but in November it was added to the sequence A163279, and thus the title passed to 12,407. From there, it moved in a similar fashion to 13,794, 14,228, and 14,972. That number now appears in at least 6 sequences, and I'm not sure what number has taken its place. Maybe the paradox is true after all, and every number is interesting as long as you're willing to look hard enough. Alternatively, you could argue that being the most uninteresting number is an accomplishment, but being the second least interesting is even less interesting, so the less boring things are paradoxically more boring. This is obviously ridiculous, and it results in the same conclusion that everything is interesting. This theory doesn't just apply to numbers, either. We can extrapolate it to all sorts of things. The world's most uninteresting color is a chromatic curiosity. History's most uninteresting flag is at least an example of design mediocrity. Being the dullest person at a party is a quirky personality trait, and you'd at least take a glance at any book described as exceptionally boring, if only out of morbid curiosity. There is a Latin saying, nollis est liber tam malus ut non aliqua parte prosit, or, in the vernacular, there is no book so bad that it isn't profitable in some part, or for that matter, a YouTube video. I hope you found this one interesting, because how could you not? Thanks for watching, and as always, 3.1415926535897932384626433832795028841971693993751.